Hello all, welcome to this vlog which is called as what is IPv6. My name is Satya and I will be explaining about IPv6 addressing scheme. First of all, the first question would be what is IPv6? IPv6 is a network addressing scheme which is represented by 128-bit address. So bit is a binary value. So you will have 128 bits as part of the IPv6 address. So the first question again would be to understand how many such addresses can be formed by using IPv6 addressing scheme. The answer is you can have 2 to the power of 128 addresses. So which is quite a huge number, right? So it's not going to deplete or we cannot run out of IPv6 addresses for a long time. Okay. Then next question would be why IPv6? Due to the potential depletion of IPv4 addresses in IPv4 networking scheme, we have to use IPv6 address so that we never run out of IP addresses when we have to connect to internet. So simply said that to avoid depletion of IP addresses, IPv6 is the answer to this problem. How IPv6? How is IPv6 implemented in the network, right? So let's take an example of residential IPv6 router which supports IPv6 addresses. Residential IPv6 routers contains two interfaces. LAN has four interfaces usually, but the WAN Ethernet side would be only one, right? So I call LAN 4 interface also as one interface. So logically at the IPv6 level, you will have WAN side and the LAN side. On the WAN side, your IPv6 residential router will get or will use DHCP v6 client application to get a /56 prefix from the DHCP v6 server in the ISP router. Like for example, your residential router, that is your Wi-Fi router, has a connection with Airtel Bharti. Then Airtel Bharti DHCP v6 server in the ISP network, backbone network, will provide /56 prefix to the WAN side of your residential IP router, which is there in your home. /56, friends. So using this /56 prefix provided on the WAN side, it will construct /64 prefix on the LAN side so that it can distribute those /64 addresses on the prefixes on the LAN side. Now the question again would be how many such /64 addresses IPv6 prefixes can be formed on the LAN side for distribution? Answer is very simple. So you got on the WAN side /56 prefix and you distribute /64 addresses /64 prefixes on the LAN side. So answer is 64 minus 56, that is 8 bits are used. So to convert it to decimal, you have to use 2 to the power of 8 such 64-bit IPv6 prefixes can be formed on the LAN side to be distributed for LAN hosts like mobile hosts and laptops. Now, how shall we distribute this 64-bit prefix to the LAN side? Answer is simple again. You should enable router advertisements on the LAN side. So when your laptop or mobile phone starts up IPv6 stack or IPv6 addressing scheme, it sends a router solicitation to the next hop router. So next hop router in your residential home would be residential IPv6 router. Upon receiving the router solicitation, your IPv6 residential router sends router advertisements with /64-bit prefix. Either your residential IPv6 router sends router advertisements, IPv6 router advertisements on reception of router solicitation from the host, or it sends router advertisements on a periodic interval of say 5 minutes. For example, it is configurable parameters. So if every 5 minutes you will send a router advertisement to the downstream hosts, which are mobile phones and laptops. Upon receiving this router advertisement, your mobile phone or laptop constructs a 128-bit IPv6 unique address in the network. How it is formed? It appends an interface ID to this 64-bit prefix provided by the residential IPv6 router. How is this interface ID formed is each interface on the mobile phone or your laptop is represented by a hardware MAC address. So this hardware MAC address is converted into 64-bit interface ID. So that is appended to your 64-bit IPv6 address to form a 128-bit complete IPv6 address, which is unique throughout the network, IPv6 network. So friends, this is how IPv6 addressing scheme is implemented in the network in a very simple way. If you want to know more about IPv6 addressing scheme, IPv6 operation in the backbone network, please subscribe to this channel and comment or put a comment in the comment section so that I can individually answer to each one of you. Thank you. Goodbye.